Let's explore our second strategy for graph search, namely depth-first search. And again, like with breadth-first search, I'll open by just reminding you what depth-first search is good for, and we'll trace through it in a particular example, and then we'll tell you what the actual code is. So if breadth-first search is the cautious and tentative exploration strategy, then depth-first search, or DFS for short, is its more aggressive cousin. So the plan is to explore aggressively and only backtrack when necessary. And this is very much the strategy one often uses when trying to solve a maze. To explain what I mean, let me show you how this would work in the same running example we used when we discussed breadth-first search. So here, if we invoke depth-first search from the node number S, here's what's going to happen. So obviously we start at S, and obviously there's two places where we can go next. We can go to A or to B. And depth-first search is underdetermined. Like breadth-first search, we can pick either one. So like with the breadth-first search example, let's go to A first. So A will be the second one that we explore. But now, unlike breadth-first search, where we automatically went to node B next, since that was the other layer 1 node, here the only rule is that we have to go next to one of A's immediate neighbors. So we might go to B, but we're not going to B because it's one of the neighbors of S. We go because it's one of the neighbors of A. And actually, to make sure the difference is clear, let's assume that we aggressively pursue deeper and we go from A to C. And now the depth-first search strategy is again just to pursue deeper, so you go to one of C's immediate neighbors. So maybe we go to E next. So E is going to be the fourth one visited. Now from E, there's only one neighbor, not counting the one that we came in on. So from E, we go to D, and D is the fifth one we see. Now from D, we have a choice. We could either go to B or we could go to C. So let's suppose we go to C from D. Well, then we get to a node number 3 where we've been before. Okay, and as usual, we're going to keep track of where we've already been. So at this point, we have to backtrack from C back to D. We retreat to D. Now, there's still another outgoing edge from D to explore, namely